Yeah. Yes, sure. Finding bugs is always good. It should be rewarded. Okay, so we were last time on the wild match function, which was supposed to match a wildcard pattern to a given string. Um, let's see. So would Mr. Leo want to continue? Okay. Yeah, no problem. Yeah, so try to connect to the virtual machine. It should be working. Should I maybe check the... Yeah, it worked. Yeah. So, is it clear what the function should do, or shall I explain it again, just to be on the safe side? So a short summary, what we did last time, we wanted to implement a find function which takes wildcards, or rather wildcard expressions. And to implement this, to make it simple, we said that we will first implement a matching function, which then could be used as part of the find function. And there's one more thing to this wild match function, namely that we should not just return true or false, but it would be very useful if we return the length of the pattern which we matched. So if it returns 0, it means it didn't find anything. But if it returns a number greater 0, then it means it is a match, and it gives you the length of the match. Although, let me think. It's also not the most perfect thing, because normally you want to match a whole pattern. You don't want to match. Let's just stay at Boolean. I think that will be also fine. That should work. So the idea is that the function should match text as in the comment above. So it first matches, as long as there are no asterisks or question marks, it matches exactly. And as soon as it finds an asterisk, then it looks on the next character after it, and then it looks for wherever this next portion of the string appears. So we could try implementing this, or if this does not work, I have this an already implemented function somewhere, so we could use this one and then continue from there with the find function. But I would say it would be good if we successfully implement it on our own. And so there is another strategy for implementation. So if this going ahead and just processing the string as it comes seems too convoluted, what we also can do is we can take apart the expression into a list of constant parts. So the pattern blah asterisk bloop would be splitted in one string blah, and so in a list of expression, in first blah and then bloop. And the idea with this method would be that you are searching for the first string in your list, then you're searching for the second string in your list somewhere further down, and you repeat this until you found all the strings you were looking for. So this might be it is more computation intensive, but might be easier to implement. So if you want, you could try this strategy as well. The advantage is that here you can break the problem apart into easier to handle individual sub problems, so to say. Sorry, if what is still here? Oh, that can happen. Yes. We already have. Don't we already have a tokenization function? I think we have one, so we can just get the result out of that. Find substring. I think it's further down. And we use this std list as a result. I think further down. Replace split. We have split, and it gives a vector back. So we can use this function. There is one thing that will need to be taken into account, that if you have like 2 asterisks or 3 or any amount of asterisks larger than 0, then you will end up with a few empty strings. And then when we will be processing this list of strings, if we encounter such an empty string, we just go to the next, because semantically the amount of asterisks is irrelevant. We will only split at the asterisk, and if we encounter a question, we have a problem. We have a problem because our implementation is made such that it can work with either sort of string, but what we pass to split needs to be either a white string or normal ASCII string. How do we work around that? Okay, I quickly. So this function took a normal string. We have an append function that takes a whole string. We'll make a append function which takes only a type t, one character. Let's call it pushback. T. Okay, so we take this. Okay, the top of this we don't need. This we don't need. Then we get the string. If this is null, then we have a problem. That will because we don't have this thingy. So if this is null, then what was it? Was it called create string or allocate string? We had the function for that. Did it create? Yeah. Create null. Will that work? So length can be null, that's fine. So create null. New string, yeah, this is fine. Data, we don't need data. Wait, we need realloc, new size. This one will be just +1. And data at length will be just equals signature. Yeah, let's call it like this to be consistent with our. And length is new size passed. So this is not the most elegant thing or a way of doing it, but this is the a reasonably quick one. So x string vom Typ T sep und jetzt sep.pushback asterisk. Okay, the reason this works is because a ASCII asterisk can be mapped on a white kite asterisk just fine. So we can push back 1, and here at this point we tell it which type we have. And now we have just a string which contains 1 asterisk, and it is agnostic to which type of character we are trying to use here. Okay, you can continue. Well, we create a CX string and then we append 1 asterisk to it. And this way we will have either an ASCII CX string or a white CX string, depending on which type, with which type we have instantiated the original variable of the string on which we are executing the wild match. So now you have a list of tokens, and now you can go through the list. And what you want to do is you want to start matching, and whenever you encounter the next token, then you would use a find function to find the next token within it. Although one thing we have to take into account is that we want within the pattern the question mark symbol to have the meaning that there can be one arbitrary character at that spot. So you would need to create an own find function which which works like this, or just implement a simple find here. So it's not, as you see, it's not super trivial. It complicates itself as we progress. But let's see how far we go. The find we already have does not handle the question mark, but we can use it for the beginning and later improve it by using a different find if we have time for that. And you need to search on string, on str. Yes, it returns an index. There is one more thing that I see we need to add, is that this matching function should take an index at which it should start matching, because we'll be passing it a str, and we don't want. Maybe, you know what? Maybe we can implement it without having to use this wild match function. You pressed something and then you press something else, and then now the thing is trying to find a definition of memcopy somewhere. But we don't need that. Yeah. Let's maybe really try to make this into one function again. May I quickly copy a few things? Because we started it one way last time, and then we continued, and so we have our wild string, we have cert. So first we have our tokenization. indexes for that. So we have our tokenization, we have our wildcard pattern. So this is what we will want to split here. I don't think we will need this for now. Okay, and then we have our extern loop where we go through the main string and search, so we iterate through different ends, and then we will try to find. Okay, but if we will be using the normal find function, we don't need this either. If we are using the normal find, it didn't copy it. Shit. Okay, and the strategy would be this. So we have our tokens. We start for the first token. Now we use the find for this token, but we need to find at the offset, at the start offset. So we will copy the start thing. Although we probably can just update it. Let's go with start. So we use. Why is find not offering? Because we now need to make find on this. Because we don't find the same function. We have find, we have string, and we have the start offset. Okay, so we find the first entry. So let's say in this example we find blah. We have the index of blah. And when we have the index of blah, then the next step will be to update start to point to the index, to the position where we found, actually the position after blah. So you can write down that the next start, and one thing, if we don't find, then we just return. So if index is -1, then you can return -1 because it means we have not found the pattern. We start at 0. It is the beginning, or rather we start at the position where the user told us to start, providing the start variable, which we have at the top. First we handle the case if we don't find it. Because if we don't find it, then we can already abort with return -1. And if we found it, then what we do is we check, we set the start position to be just after where we had this match, and then we repeat the loop. And there is one more thing we will need to do, but that's for later. It must return the position, so that there are a couple things that there are 3 things you still need to add. One is start should be not incremented by index +1, but by index plus length of token at the position I, because we want to go the whole word and not just a proportion of it. The second thing is we want to save the first index result. So the first index that we obtain should be saved into a helper variable. Yeah, IntelliSense is not so intelligent sometimes. I think we have the length function. You can check it just by searching for it, or maybe we named it find token. Oh, I see a small bug. When you initialize CX string, when you go back, when you initialize CX string, the line 129, the vector with the CX string must be told the type it should be initialized with. Probably this is where IntelliSense got confused. Try again if you now get the length. It's the just Control F for length with brackets, and then we see whether we call the function length or if we called it somewhere. Yeah, we called it length, so it should be fine. As I mentioned the last time already, IntelliSense with templates is kind of broken because the code is not complete until it's instantiated and used somewhere. Okay, so this one thing. The second thing is you need to save the first value the first index that you get returned, and this will be the return value that we return if we find all the rest. You don't need the I, you only need because it will always be 0. Well, not always, but usually. You only really want the first index returned in line 136 during the first time you get something out of it. And one might think that the simplest way would be just to save it if I is 0, but we have a special case where I might not be 0, which we need to add first to the handling. So I would say the simplest way would be to write in line 131 index is equals -1. Set first index in the second line also to -1. Under the second line we need, the third line can go. Okay. And now assign in line 135 to a temporary index, like temp index or something like that. And you need to give it a type. Yeah. And now you can check if index is -1, then index is equals temp. Sorry, then first index is equals temp. And in the second line you can write we don't need the temp. I overcomplicated things. You don't need to type the second line. Let's change it. Changed line 113. Yeah, this one can go. 135. You just assign index temp. So assign the value to index. And the check in line 136, you make just first index. If first index is -1, then it's equals index. That's yeah, perfect. So we have saved this. We have the return case. So one more thing to think about is the scenario I mentioned before. If someone would have typed 2 asterisks, one after the other, or if someone would make a string which starts with an asterisk. So you should check, you should add a line between 134 and 35 in which you check whether token length is 0, and if it is 0, then you just continue to the next entry. Oh, and we are missing an I++ in the for loop. Because if we have multiple asterisks, they are all to be handled as one. So it's fair to continue to the next and the next, and so on. Asterisks, yes. Or if the string would start or end with an asterisk, which also would be just fine. Okay, so we have this, we have this, we have the right return, we have the special case. Could be working. Let's try it out. Yeah, here you have your test case region area. Okay, we need to make the my string more interesting. Or you can search for A, B, C asterisk, or maybe yeah. For a first test is good enough. Let's run it. So the result of, you can maybe comment out the two other test cases. So the result we are looking for is the number 1, which should be working. Okay, it doesn't like something. Token. Didn't we not call it length? Ah, yes, you need to take from I. Okay. One less. Is split defined as const? It's not. You can define it as const. Yes. Why is it complaining? Just try running it. I don't see on the first glance why that should not be fine. Yeah, it is fine. Just the compiler. Sorry, the IntelliSense was confused again. What did I scrap in the pushback function? So we have our pointer, which is, do we have it create null from length should be fine, +1. That should result in a non-zero string. Let's the pointer is length. Sure. Okay. Then we will. Yes, we will try to make it work in the meantime. Yeah. Okay, so the problem here was that we created a new pointer, but we have not. I would think that this was everything. Let's step through it. So pointer is null. This is what we expect. Then we make create. Damn it. Create does not assign it. That's the right way to do it. I said we don't need the breakpoint anymore. Oops. So what did we get? 1. That seemed to have worked. Then let's try a more sophisticated test pattern. Okay, we managed to repair it in the meantime. So that's the right way to do it. I forgot that create does not assign the pointer. It just creates a one without doing anything with it. And now we can make a better test case. Test blah 1, 2, 3 text abc 6. Okay, that looks like an interesting test case. Let's start with something very screwed up. To asterisk, then a blah. Asterisk bloop. Asterisk. Let's screw it up maximally. Bloop. 4, 5, 6. And let's have no asterisks at the back for good measure. So where we would want to start at plus, so that should be like 0, 1, 2, 3, 4, 5, 6. I think I counted one too much. 5 or 6 it should be. Let's see if this works. And if this works, yep, 5. Nice. Then, first of all, we can clean up the pattern because we know the multiple asterisks handling is fine. And the next thing we should add to our wild find will be the ability to return the found length, so that we know how long the pattern is which we matched. Would you want to continue? Okay, then please connect. And the way we will do it is by adding a new parameter, which will be a pointer to a size t object. The third one. Yes. So you just need to scroll to our find function and then add after size. It was there already. Sorry, no, it wasn't. It's fine. It's fine. It's here. So not too much. So well, find yes. So what we will want to do is we'll want to add an additional parameter after start, which will be a pointer to a size t variable. P length, for example. And we initialize it to null in case we are not interested in the length. Capital null. Yeah, and the simplest way to do it is to calculate the length while we go through the loop, and then at the very end check. And save this to a temporary variable, and then at the end check if p length is not null, then assign it, and if it is null, then we just discard the value. The length of the match. So if we go back to may I take the mouse for a second? So if we go back to here and have this pattern, blah bloop, that is how many characters? This length, 36. It should return, in this case, the number 36. No, 36 is the length of the whole thing. It will be less. It will be -8, so it will be 24. Or something like that. So, how can we do this? The simplest way would be to get this, to just get the end index, so the last position, which we in fact have in the shape of updating start. I think it might be as simple as just I think it's as simple as just start minus first index. Yes. There is a bug, but let's run into the bug and see the crash. Yes, no crash today, or maybe at least not now. Yes. And we need a test case. That would be fine. You just need to add 0 as a start parameter. You can do that. No, I mean in the line 100, you forgot to type comma 0. You were trying to assign the pointer to the start variable. That's why I didn't like it. Okay, 26. Good enough. I think it's right. I just miscounted the count of bytes. Yeah, because test is of course 4 and not 3 characters long, and it also adds the terminating null to the length when it tells you how long the whole array is. So that will be fine. So this is working. So the only thing missing in our while find function now is the ability to handle a question mark as a arbitrary character. So now we will need to go back to our find function. And let's see how we can intelligently replace that. So one option would be to modify the the normal find to add an additional parameter which enables well, question mark to be anything. Or the other option is just to copy it and hard code the question mark is anything somewhere. There is, well, it would not be probably super elegant to expose a function that works like this, but what you then could of course do is rename find, set it as private, and then have a public find which does not take the additional parameter, and then have a private find which takes the additional parameter. I mean, it's the easiest way, so let's just go with that. Or you copy the whole function. This is also a fair approach. Okay. Then let's do that. Const. Okay, and to rename the other find to find underscore EMPL or something like this. So like find implementation impl. Then you will just call find impl from find, and to find impl will get a third argument. Yes. Do we have a private somewhere? Here, protected is fine. It doesn't have to be private. Protected is fine. Just put it at the end of the class. Okay. This is up to us. So we could either make it a bool, and then it will just enable or disable question mark, or it could be a char which just takes the character you want to be, so that you could instead of question mark say ignore minuses or something like that. Let's go with with a char. Just give it a name, and by default make it not 0. And 0 means that it will be ignored, that this function is disabled. Where do we have our compare function? There it is. Oh, I have an even better idea. I have a much better idea. we can add a whole set of what do we want the find how do we want the find function to behave, of a set of flags. So just Control Z, put it back where we find it, because this will be useful also in public scenarios. So we don't use a bool. Just Control Z a couple more times. Yeah, and you don't need this. This one you can remove impl, and we call we make an enum called find options. And first entry will be, of course, I don't know, option none, which is a 0. Then we make option wild, which will mean what we want to initially, that it ignores question marks. And then we'll add another option, option case insensitive. It's a bit long, but well, why not? Which will be 2. And then we can change the, let's for now just focus on the first option. So you add additional parameter to our find of type find options. You need a semicolon in line 86. Yes. Find options. By default it will be none, but we will be able to just then use the option wild, and it will then ignore our question marks. Yeah, probably. If we don't add any other options where we would also have none, then it will be fine. Okay, and now you can change it such that if option none is set to wild, it ignores question marks. Yeah? Here? Yes? Mm-hmm. Um, if we don't do anything, if we don't break the tool, the index will be set for forth automatically. But you need to check whether at this index in the string we are looking for, the question mark is actually a question mark and not just anything. I think so. Mm-hmm. No, for single characters it's fine. would not necessarily be valid. We have some code further down which we would want to execute in case of a match. So the code as written now needs some improvements. Basically what we would want to is if those two characters don't match, then then check if the wild option is set. If it is set, then suppress the error, and if it's not set, then break. So I would rewrite the code block from line 109 to 115 and make it differently. But you can keep it. Portions of it are good. You just need to plug them together differently. Basically, you could do one large if instead of the whole thing, and if this if is true, it will break, and if it's not true, it will continue. You just need to figure out the right content for the if. Yeah. You said if it's not, you need to make the not. Yeah. And if it's not a question mark, it will also break. So no, that will not work. You need a or in your if. Because if it's not wild, or if it's not a question mark. So a normal find, then the first case will trigger. If it's not wild, then it always breaks. And if it's a wild find, then it only breaks if the character in your pattern is not a question mark. And if it is a question mark, then it behaves as if the match would be fine and continues to the next code block. Mm-hmm. Well, the idea is that the question mark will match all chars.
Won't this be?
If you have multiple question marks, this means that you have multiple arbitrary characters in your string.
Okay, so this is fine.
Yes.
And now there are two more options.
Well, the none option does not do anything, and the case insensitive option we will add later to change the comparison in line 107 to be case insensitive. So now you just need to apply the new option to your find invocation in your wild find implementation. Line 144.
Actually, we just named it.
We just called it wild. Yep. Okay. It's time for a test case. Yeah, for example. Is it called find options? And is it called wild? Find options. The type is missing. You need a name. options or opt, yeah. It's working
Okay.
perfect. Okay, so the wild function, so the wild find works fine. So now maybe a task for our other participant.
Yeah. Sorry, I'm always taking a lot of time.
Yeah, no problem, Mr. Sebastian.
Yes.
We had a very good idea with adding the case-insensitive option to our find function. So maybe you would want to implement that, and also add this to the reverse find.
Yes. So I guess we only deal again with characters like between lowercase a
Yes,
and lowercase
like
z. So
exactly.
this comparison needs to be, in that sense, a bit more elaborate. So maybe we should check if I was thinking of checking if, first of all, ptr p-data and substring p-data are like within lowercase a and lowercase z. Or could we use the two upper or two lower?
Yeah, but that would be inefficient.
We're lazy, yes. Okay.
Well, I think a good approach would be to first go into. So we only care for checking the other cases if we are within, if the match in line 109 didn't match. So, and so we would, after probably the wild find, check if option is. Oh, I see another small bug. The option is ungleich wind. We would want to check the whether it's set as a bit field. So if option and wild is null, then we break. Is 0, and I think we need to put it in brackets just to be on the safe side. And then the same sort of check you should use for the uppercase, because now we will be able to even combine wild find with case insensitivity, which is nice. So just check if the other flag is set, and then
now, I should check that if opt
and ignore case.
And how was it called? No.
I think ignore case insensitive. Okay, the longest possible name.
Opt and case insensitive. That should be then 1, or?
Well, it should be not null, because when then it would be 2, but we just go with not null. And then inside this we can wait, let me think. No, this needs to be first, because the upper line will break out before we come to the lower line. Yes.
So we would need to no, let me think. I mean, in some case we can't no, but the question mark doesn't matter if it's upper or lowercase.
Yes.
So if it's not the case, it's guaranteed that there could be let's say we match for an A, so we can only have let's say these two cases if we run into this, that they are of different case, but we don't know which one's which. So we could do something like if ptr p-data, if this is, we could always convert to lowercase. We could say if this is greater than greater than z,
we could try to be so we have these two upper and two lower functions which work on the string level. We could extract the portion of them which works on the character level to separate helper functions, and then here use those for the comparison.
Okay.
Because if we only do this on single characters, that this is fine. The computation intensive part is to allocate a new string which we need for the new for the normal string based upper and to lower. So this is what the creation of the new string is what we want to avoid. But just one function invocation, that's just one instruction, that's super quick.
Trim
To find it somewhere. Here it is.
upper. So we could actually do
Well, T, not char, T.
T.
To lower from T, CH. No, from T I mean brackets, to lower brackets T, CH, and so on.
That's const. That should probably also be a const and maybe a reference.
No, it's a character. It's super quick to copy.
So that's essentially this one.
Yes. Pretty much. We can then use it in our to upper and to lower function. So if we improve them at some point, then we have the improvement already everywhere.
So that should be CH. CH.
And that's just a.
Oh, I need. Sorry, yes, I need. Of course, it's a T. That would make more sense to set.
You can just assign it to CH, make CH not const. You can reuse the CH variable. Just assign it to CH and remove the const.
Okay.
Mm-hmm.
And that should be assigned.
Mm-hmm.
No. And the same for the to upper.
Mm-hmm.
Actually, just
oops, that was a small
okay,
mistake.
let's remember that. Let's maybe first do the to upper. So
the to upper is correct. The to lower is it's not correct. Because you took the code from the top, I think, which was to upper.
yes, that's right. Complete chaos. So now the two lower. It's just that a plus result. Yes, that should be good.
Yep. Here. Okay.
And maybe put these below. It's a bit strange.
Mm-hmm.
Okay. Where were we? Was I find?
Find. Yeah, here.
So here now, if it's larger than Z, we.
Well, you can just use that to lower. So to lower from p data e plus j and to lower from the other p data, and then just compare them.
Substring. Okay, but what to do if they're equal?
Then we want
Continue.
to jump. Well, we need the code below, so I would make a label, either in line 127 or in line 124, and then just use goto to go to that label.
Sorry, how to, I was thinking of just putting in like a flag.
Label is more elegant. You just write the name of the label and then double point. You can call it skip over. And then you
What?
just write go to skip over.
Well, I think I've never done that before. So go to
Space, skip over.
space, skip over. Should it
In Strichpunkt.
with?
With the semicolon at the end.
Yes.
Yep, that should be working. We need a test case. So using gotos needs to be done with a bit of care. For example, if you define a variable somewhere between your goto and the label, then the compiler will throw an error unless you define it within a code block. So if you are using gotos, then one strategy would be to define all your variables at the beginning of the function, or just to take care where you put them. Yeah.
So that should be.
Gotos are also very useful if you want to break out of two loops at once. So normally you would need to set a flag in this inner loop, which will break the outer loop, and then break the inner loop, and then have the flag breaking the outer loop. So it's complicated. Or you just put a label after the second loop, and then just go to the go to the label after the outer loop. This way you can break any amount of nested loops you want, as long as you don't run into the variables not being properly deallocated issue. But as I said, the compiler will not allow you to use a goto if there would be an issue like this.
It's almost a bit assembly like the goto. So how do I get the case non-sensitive?
You need a cx string from char, double point,
cx string dot.
No. You need Spitze pointy brackets, then write char.
That's why I didn't. And like.
Yeah, and then double point.
Okay. And then
we don't have a length.
Length is not necessary right now. You should find it in the fifth spot.
That's particularly annoying. You cannot have end a code block. You need some instruction after your skip. Now, just move it to line 120. Then you'll have the if. Wait, no, sorry, that's bullshit. 129.
So here.
Yes. That's the next limitation. You need to have some instruction within the code block after the skip over, otherwise it won't work, because otherwise it will not know. Oh, that's very wrong. Well, no, it means returned -1. I guess it is not printing it properly, but this means that this somehow didn't work.
There's two lower missing.
Yes. That explains it. No. Okay, then let's put a breakpoint here and see what this thing is doing. Maybe put the end operator with the two operands in brackets before they're not 0. Like the standard mathematical operations there, you can rely on the right order being maintained, but with the logical operators.
Really? Yes.
Yeah, it does not take any weight for it. Like is not equals is the same as a by bitwise end. Okay, but this is working, so very good. now we would want probably to add the same options to our reverse find function, and then we see where we go from there.
Inverse, copy and paste.
Pretty much.
Where's the reverse?
It's below the, yeah, here. And you need to add the options flag to the,
Yes.
yeah, here.
So we could find up. Oops. I forgot it again.
Fine.
Underscore.
You don't need to make things const if you are not using pointers. I mean, it depends. If you want to make sure that no one will change within your function the value of option, then or opt.
Yeah,
we call
that's
it
usually
opt.
the case that I don't trust myself. But
Okay, then yeah, it
okay.
equals none.
Okay. So
Not quite. We
There.
want when you want to be inside the
Oops.
yeah,
in this one.
yes. Yeah.
So that should certainly now be correctly indexed.
Yes.
And then the skip over is first of all missing. Oh no, not here.
Yes.
And should
Yeah, wild find can stay.
yes.
So should be good. Let's try it.
Correspond twice open.
How did that happen? Usually it shouldn't open the same file twice.
Oh,
It's not 0. I think the start offset must be -1 if we are using the rfind function. Yep, perfect. Okay, so for a good measure, also a reverse wild find, maybe would be a low-hanging fruit to implement at this point and might be useful.
that's a bit of pressure.
Why?
That's a low-hanging fruit. Okay, it's the R wild find. So
Yeah, this default is
Sorry.
-1.
should be -1. Then we have that should be the same. So here we would need to go from the token.size -1 to
Yeah.
equal 0 minus. That's okay. That's an R. That would be an R find.
Probably.
Start to wild. Okay, this expression is now
We need the last. So actually we don't need
Yeah.
that. We'll just use the last index that fell out of the operation, since we are working in reverse.
So sorry again. I'm lost on this line. What was it again for in the wild find? I was
Because we wanted the index of the first entry we find, because we want the offset from the beginning of the string.
yes. Okay.
But
okay,
here
so
we
that-
don't need it,
We
and
don't even need it. So
we
we
can
could
just
then
use the
first-
index variable at the very end of the loop. We don't need first index either. We'll just use index as the well, from now on.
Okay. That's
Yeah, if it's if it's -1, then we break because we haven't found the next entry.
yes.
This one will need some fixing.
Start is the current.
Probably mean minus.
Yeah. Does it make sense? The index is something like that. Yes, this could make sense. Okay.
And here just index instead of first index. Wait. Start? Is it the... that will need to that will need some fixing because start might be if there would be only one entry, it would be then still -1. No, we always change it unless we would not have any expressions.
So
the length is a problem. We probably will need these two variables, just that they will then be called last index, and then we will use last index minus index. So Control Z twice.
yeah. Let's see.
One more.
This one. Oh, come on.
Yeah, we rename first to last.
Yes, okay, I see the problem.
But it's really only because we want the length. If we would not care for the length, we could simplify things. And in line 189, we change the sign.
Yes.
And then it
And
will be
why-
last index
wildcard.
minus... No, last index minus index.
The wildcard search is really hard for my brain to return index.
Wait, is that true? Index will find the first index reversely. It should be fine. Let's try it out. Yeah, it's a bit convoluted to implement, but it's very useful because you have a very simple means later on to match patterns. The patterns are very simple, but usually it's already enough to just say, okay, and here is a random placeholder. And if you want then to say, okay, but I would like here to be only large characters, there to be only lower characters, and that should be followed by only numbers or something like that, then there really is no good way around using regular expressions at this point anyways. And
So it found the length, but the index is -1. It's interesting.
then we have screwed something up. Wait, is it? What did you replace it? Did you replace the second test case?
I just did the reverse.
Yeah, because 0. Oh, and
Oh,
actually it should not have found the right length. Sorry, it's the wrong error find. Yes, okay.
It still doesn't work.
It still doesn't work. Step through it step by step, I guess.
Yes.
What they want to say? Yes. That Qt has a regular expressions class that you can use, and for C++ there is in the extension of the STL library called Boost, which is pretty much just a playground for new C++ standards, a regex class as well. To be honest, I don't remember whether they already included this in the standard C17 or not. But if not, then you can just download it separately. And then you can have really arbitrary patterns.
So that was 456, and it found it at. That's good. I guess 28 should fit the bill.
Sounds reasonable.
So last index is now 28. Index is not it. So start is 28 minus the length, which also sounds good. So now we are matching, I guess, for the what was it?
9
And
seems
that also
fine.
makes sense.
Yes.
So last index stays at 28. That's
Yes.
so good. Start is now 5.
What is it looking for now? What's in token I?
Blah. And that's at 0. So it's a rep.
No, in the in the original in the original string. I think the minus is wrong. We should just have start like index. We don't need the minus token length.
Yes, I see. Let's go.
Yes.
Yes.
Wait, why did it say 23 and the other one said index is the begin, last index. Last index must be index plus plus length of token.
Yes.
Success. Cool. Okay, since we only have 10 more minutes left, I guess that's a good point to finish.